Nuclear power. It gives us a huge amount of carbon-free energy, right? But it comes with a catch, a really big one. A toxic legacy that stays dangerous for a truly mind-boggling amount of time. Today, we're going to dig into that challenge and look at a first-of-its-kind solution that is just now coming online in Finland.
So let's just jump right into the big question. I mean, think about it. What on earth do you do with something that has to be kept safe not for 100 years, not even for 1,000, but for 100,000 years? That is the absolute core of the nuclear waste problem.
All right, so first things first, let's really break down what we're talking about here. You have to understand the problem to really appreciate the solution.
The real headache, the thing that keeps everyone up at night, is what we call high-level waste, or HLW for short. This is the most intensely radioactive stuff, mainly the used-up fuel rods that come straight out of a nuclear reactor.
Now, not all nuclear waste is created equal. There are actually three main categories. You've got low-level and intermediate-level waste, and they have their own disposal methods. But it's this high-level waste that is the real monster. It's the stuff that demands the most extreme, long-term isolation from us and our environment. So, if we don't have a permanent place to put it, what have we been doing with all this high-level waste for the last, 50 or 60 years? Well, the answer is essentially a highly engineered, very sophisticated waiting game.
Here's the current playbook. Once those spent fuel rods are pulled from a reactor, they're incredibly hot and radioactive. So they immediately get plunged into these huge water-filled pools to cool down. After several years, they're cool enough to be moved into these massive, above-ground containers called dry casks.
And this is the key. These dry casks, made of thick steel and concrete, are incredibly tough. They're designed to be safe for many decades. But decades is a drop in the bucket compared to the 100,000 years we need. It's a stopgap, a holding pattern. It was never, ever meant to be the final answer.
And not every country handles this temporary phase the same way. The US generally just stores the spent fuel rods as they are. But other countries, like France or Japan, they take a different route. They actually reprocess the fuel to pull out usable plutonium and uranium for new fuel. This reduces the final volume of the high-level waste, and what's left over gets locked into a stable, solid, glass-like form. That process is called vitrification.
So this holding pattern was never the end game. What is the internationally agreed-upon permanent solution for all this stuff?
You'd be surprised how unified the global scientific community is on this. The consensus is crystal clear. Deep geological disposal is the only viable long-term solution. The idea is to basically put it back where the uranium came from in the first place, deep inside the Earth.
So what does that actually mean? Well, it means taking that waste, sealing it in incredibly strong containers, and then burying it in extremely stable rock formations like granite, anywhere from 250 to 1,000 meters underground. The geology itself becomes the ultimate containment barrier.
But here's the crazy part. Even with decades of agreement that this is the plan, no country had ever actually built and opened one of these permanent, deep repositories for commercial nuclear waste. It was all just a concept. Until now.
And that brings us to Finland, and a project with a name that literally means cavity or hiding place, the Onkalo repository. And just look at this timeline. It really drives home what a massive, multi-generational effort this has been. The search for a site started way back in 1983. Construction didn't even begin until 2004, and now, over 40 years after the whole process started, it's finally hitting a critical moment.
And to give you a sense of scale, this is how deep they've gone. 430 meters down. That's about 1,400 feet, burrowing straight into ancient, stable granite bedrock. To put that in perspective, that's deeper than the Eiffel Tower is tall.
The whole safety system is built on this idea of multiple barriers. It's kind of like a set of Russian nesting dolls for nuclear waste. First, the spent fuel is sealed inside a massive copper and iron canister. That canister is then wrapped in a buffer of something called bentonite clay, which is amazing because it swells when it gets wet and seals any potential cracks. And then the final and most important barrier is the ancient, stable granite bedrock itself.
The scale here is just immense. The project cost is well over €1 billion. It's designed to accept waste for about 100 years, and then, sometime after the year 2120, it will be permanently sealed, never to be opened again.
And this is why we're talking about it right now. In August of 2024, Onkalo hit a massive milestone.
They successfully completed a full trial run, basically a final dress rehearsal, placing non-radioactive test canisters into the tunnels. This is the last big step before the real operations begin, which is expected in the next year or two.
But even as this historic facility prepares to open, it's not without its critics and controversies. In fact, Finland's solution has only fueled a never-ending debate about our responsibility to the future.
There are really two major criticisms. First, some scientists question if those copper canisters can really resist corrosion for 100,000 years in the real world. Second, and this one is maybe even more provocative, others argue that burying this fuel is incredibly wasteful. They point out that this so-called spent fuel still contains over 90% of its potential energy. To them, burying it is like locking away a massive energy source that future technologies could one day unlock.
This all leads to a profound, almost philosophical problem. How do you warn people 10,000 or 50,000 years from now not to dig here? What language do you use? What symbols? This challenge is so huge, it's actually inspired art and documentaries, like Into Eternity, that grapple with this very problem of communicating a warning across deep time.
Which leaves us with this final central question. Onkalo is an incredible feat of engineering, designed to solve a 100,000-year problem. But is burying our most complex waste the ultimate act of responsibility? Or is it a profound failure of imagination, sealing away a powerful resource that future generations might one day need?